So have you ever come home from a long plane ride only to open your suitcase to find your shampoo and toothpaste explode all over your clothes? That's happened to me a few times, and I kind of wanted to know why. And the reason is due to Boyle's law. Boyle's law was discovered by Robert Boyle, coincidentally, in the 1600s. He was in Ireland. He did some chemistry back then. And he discovered that the volume of a given amount of gas held at a constant temperature varies inversely with the pressure. All right, so what does that mean? Let's look at this picture, and this actually helps us describe that. All right, so let's say I have a canister of gas, 10 liters of gas inside, and I have a pressure of 1 atmosphere on there. If I take my constant, multiply pressure times the volume, I find that we have a constant of 10 atmosphere liters. Okay, fair enough. Let's say I push down on that canister. I push down on it with twice as much pressure, so now my pressure is 2 atmospheres. What's going to happen to the volume? Well, you guessed it, it's going to half. So there is a relationship between the pressure and the volume of the container, as long as the temperature is constant. So if we were to multiply these, we get the same thing as we did before, 10 atmosphere liters. So notice that P1 V1 equals P2 V2. These two sides are the same. Great. Okay, so let's go over here. The relationship between the pressure and volume, what is that? Well, we noticed that as pressure goes up, so does the volume goes down. They have an inverse relationship to each other. And also, if pressure goes down, volume will then go up. They're completely inverse of each other. So how do we graph that? Well, if we have volume on the y-axis and pressure on the x-axis, it will have a graph, and we were to graph all our points, it would have a graph that looks similar to this. Notice that this will never reach, the volume will never reach 0, and the pressure will never reach 0. That is because you'll never have a volume that's nothing, and you'll never have a pressure that's nothing. So we can have a curved graph that looks similar to this. Notice it's also a negative slope because our relationship is inverse. All right, if we were to mathematically look at Boyle's law, let's reiterate the fact that pressure 1 times volume 1 equals a pressure 2 times volume 2, as we demonstrated earlier. That's our mathematical relationship. Okay, so let's actually put this into practice. Let's say we have a sample of neon gas that occupies 0.22 liters at 0.86 atmospheres. What will be its new volume at 29.2 kilopascals? Well, the first thing you should notice is that when we're dealing with pressure, we want to make sure that pressure is always in the same unit. In this case, pressure is in atmospheres in the first scenario, and the second one is in kilopascals. I don't like that, so I'm going to put them in the same unit. I'm going to just randomly choose atmospheres. It doesn't matter if you choose atmospheres or kilopascals. It'll give you the same answer, but I like atmospheres. So I know that 1 atmosphere equals 101.3 kilopascals. Okay? So I'm going to change 29.2 kilopascals to atmospheres. So I know that 101.3 kilopascals equals 1 atmosphere. So 29.2 divided by 101.3 gives me 0.288 atmospheres. Okay, so let's start out with this. So instead of using this number, I'm going to use this number. So sample of neon gas occupies, this is my V1, and this is my P1. So 0.860 atmospheres times 0.220 liters equals, we went to our new volume, and our second pressure is 0.288 atmospheres, and we don't know our new volume. That's what we're looking for. Now, before we even solve this, let's predict what our volume should be. Our atmosphere actually goes from 0.8 down to 0.2 or 0.3, so it drops. So what's going to happen to our volume? Our volume should increase according to our relationship that we discovered earlier. So let's see if that happens. 0.86 times 0.22 will give me, hold on, I don't know that off the top of my head. 0.86 times 0.22 gives me 0.1892. Equals 0.288 V2. We're going to divide by 0.288, divide by 0.288, and we get 0.66 is a rounding liters. Our second volume is 0.66. So that match it. Volume was 0.220, now it's 0.66. It did go up, which is what we predicted. So we just proved Boyle's law.